Okay, so now what I want to do is I want to try to give you the goods and try to explain these brightness values and all that kind of stuff using traditional Ansel Adams zone system scale, if you will. Down here we've got different bit depths. Different bit depths, meaning here I have a 1-bit image, a 2-bit image, a 3-bit image, a 4-bit image, and then I jump right up to an 8-bit image. I didn't want to bother with the 5, 6, and 7. It was irrelevant at this point. What I want to try to explain to you is the number of bits in our image. If we have down here an 8-bit image, this is what our JPEG files create. And there's nothing wrong with them as long as they're properly exposed. So a continuous tone from pure black to pure white is a beautiful, properly exposed JPEG file, if you will. Now, what I've got down here is I'm showing you that we have a 4-bit image. Let's go back up to the top here and talk about a 1-bit image. A 1-bit image means that we have black and white. We have ones and zeros. We're either on or we're off. That's all that means. So now, if we were to take a look at the black and white, and in Photoshop, in digital imaging, when we're dealing with the color value of black, that is represented by the number 0. Now, when we're dealing with the color value of white, that is represented with a numerical value of 255. If you add 255 plus the 0, you get 256 levels of brightness. 0 is the first digit in computer programming. All right, so now we can see 0 to 255, 0 being a digit as well. So now we have 256 levels of brightness. That's a 1-bit image. They're either on or they're off. That's all there is to it. On a 2-bit image, we have 4 levels of brightness. We have the pure black, we have the pure white, and then we have 2 shades of gray. So now we go down into the 3-bit image, and we have the pure white at this end, we have the pure black at that end, and then in between we have 1, 2, 3, 4, 5, 6 levels of gray in there. I have an image that I'm going to show you in a second. You'll see where all of this is kind of coming together. And then when we have a 4-bit image, we have white, we have black, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 shades of gray. Inside the continuous tone 8-bit image, we have 0 down at this end, we have pure white at this end, and we have 254 levels of gray. And we'd have all these little fine little lines in there, just like you can see these separate. But because they're so smooth in the transition, we don't see these little lines in there. That is the Ansel Adams technical grayscale talk about this stuff. Let's go in and come down and get the, is this the one I wanted? Yes, here we go. So now we have this one. Here is our image that I had in the camera raw dialog box. You can see there is our image. Here is a 1-bit image. We either have black or white. No shades of gray. Black or white. Black or white. In here we have a 2-bit image where we have black, white, and we have 2 shades of gray. Over here we have a 3-bit image. And we have black, white, and we have a few more shades of gray in there. Over here we have a 4-bit image. We have black, white, and remember we had 14 shades of gray in between the pure black and pure white. And now we have a continuous tone black and white image. There you go. Now translate that over to the color image. All we're doing is putting color information on top of a black and white guy. I don't know if you guys remember this, but all images that we're working with in the digital world are grayscale, with color filters on top of them. Your camera is the same way, a scanner is the same way, and all the images that we work with in Photoshop or any other imaging editing software is the same as that. So now what I'm going to do is I'm just going to close that off. All right, now here is the actual image that I had in the camera raw dialog box at the beginning of this video. What I wanted to show is visually the image now. All right, I've shown you the 1, 2, 3, grayscale kind of stuff. I've shown you an image in these different bit depths. Now I want to show you the image itself. Okay, so over here we have the image as I interpreted in camera raw, exported it out, inside Photoshop, I brought up the levels dialog box. The levels dialog box has the histogram. What I'm going to do is I'm going to jump over to this image here. You can see that this image here is much brighter and possibly a little bit more contrasty, darker, and all that kind of stuff. What I've done is I've taken the slider here that originally started at 255, you can see it's right there, and I pushed it into there. You can see I've pushed it right down to there. I have taken the shadow slider that was at 0 and brought that in to about 20 something, and then I took the midtone slider, which is at 1.00, and moved that all the way down this end as well, lightening up the image. So now I've pushed this histogram around and I've moved the brightness values around, and I end up with, after I click OK and then come back into the levels dialog box, we can now see the histogram and what it now currently looks like. This is the histogram before. This is after making an adjustment, or I may have made half a dozen adjustments. It doesn't matter. It's all as an explanation. Right now, we go from pure black to pure white, and that's fine. These little white spots inside here, it's known as combing. Those little white spots in there represent areas that don't have information in that 0 to 255 scale. If these gaps of white are large enough, then we will have banding, if you will. It's a matter of not having a continuous smooth gradient in our image. Now, if I come over here, we can see that I have this image, which is a 16-bit version of this, and the same adjustments, whatever they were, that were done to this image, were also done to this image. And as you can see, the histogram has no combing, no blank spots, still a continuous tone. This is just another reason why we would want to shoot in 12-bit or 14-bit RAW.